And then we have some other sum to product identity. So another one is the cosine x plus cosine y equal to 2 times cosine of x plus y over 2 and times cosine of x minus y over 2. And this guy is from the identity 7. Okay, you can check it by yourself. And then another one is the cosine x minus the cosine y equal to negative 2 times sine of the x plus y over 2 times sine of x minus y over 2. And this is from identity 8. It's the one identity after another, right? You can see too many identities. Yes? So try to memorize all of them. Now, let me show you one example to see how we use this sum to product identities to rewrite some expressions. So let's go to the page 553. Let's look at the problem 18. We have the sine of the 7 degrees plus the sine of the 11 degrees. Now we need to use the sum to product identities to rewrite this expression. So this is the sine of x plus the sine of y, right? So we know sine of x plus sine of y is equal to 2 times sine of x plus y over 2 times cosine of x minus y over 2. Okay, so now x is equal to 7 degrees, y is equal to 11 degrees. Then this original expression, sine of the 7 degrees plus the sine of the 11 degrees by this identity is equal to 2 times sine of the 7 degrees plus 11 degrees over 2 and times cosine of the 7 degrees minus the 11 degrees over 2. Then you simplify. You have the 2 times sine. Okay, this is the 18 degrees divided by 2. That is 9 degrees, right? And then cosine 7 minus 11, negative 4. Negative 4 over 2, you have the negative 2 degrees. And we know cosine is even function, right? So for the even function, f of x is equal to f of the negative x. So this guy is equal to cosine of 2 degrees. And since it's not easy to find the exact value of these two function expressions, so we just leave this answer in this form. Now let's look at the one more example. Let's look at the problem 25. On the same page, we have the cosine of the 5y minus 3 minus cosine of the 3y plus 9. So first, let's get the required identity, sum to product identity. So we have this identity, cosine of a minus the cosine of b. So here I use a b and try to differentiate them from this y here. This is equal to negative 2 times sine of x plus y over 2 and times sine of x minus y over 2. Oh, sorry, I should use a and b. So sine of a plus b over 2 and sine of a minus b over 2. So right now, a for this problem is just equal to 5y minus 3, and b is equal to 3y plus 9. So this original expression, cosine of the 5y minus 3 minus the cosine of the 3y plus 9 is equal to negative 2 times sine of a plus b. So that is the 5y minus 3 plus 3y plus 9 over 2 and times sine of 5y minus 3 minus, okay, since this b has two terms, so you have to use a pair of the parentheses to enclose it. And here, so you have the 3y plus 9. And then divided by 2. Now you simplify, then you can get negative 2 times sine of the 4y minus 3 times sine of y minus 6. So actually 5y plus 3y you have 8y, right? 8y divided by 2 you have 4y. And negative 3 plus 9 you have the 6. Hold on, that should be the plus 3, okay. And this is the, okay, 5y minus the 3y you have the 2y over 2 you have the y, right? And negative 3 minus the negative 9 you have the negative 12, so negative 12 over 2 you have the negative 6. Okay, welcome back. Hard? Not so hard. So some guys say, okay, with the 2 AC on, it's too cold here, so I just turn off 1 AC. And before, there was a TA who is an international student, and in a very hot day, he went into the department office and saw the department secretary, okay, in the office, who is a lady. And then he said to the lady, "Oh, hot. I'm very hot. I'm very hot. Are you hot too?" The lady know English is not his native language and know what he meant and said, "It's really a hard day." Okay, now let's look at the page 553, problem 30, sine of the 285 degrees minus the sine of the 15 degrees. And we need to find the exact value of the sum. So we need to use the sum to product identity to find this value.